Okay, now as I said, the next topic in our syllabus is rational expressions. If you remember rational numbers, and the example of a rational number, we call it R, for example, is 2 over 3, or 4 over 5, or 9 over 11, or minus 3 over 6. Well, these are the examples of rational numbers, or fractional numbers. Now you see, in each of these numbers, we have two integer numbers. 2 and 3, 4 and 5, 9 and 11, minus 3 and 6. Now rational expressions are defined in the same way as rational numbers. As rational numbers are formed from two numbers, 2 and 3, for example, in this case, rational expressions are also formed from two polynomials. We already studied polynomials, and we know how polynomials are looking like with different degrees, ordered or unordered, complete or incomplete. Rational expressions, like rational numbers, are formed from combining polynomials. And this is actually the general form of a rational expression. I write it on the board. A rational expression, we call it R, is equal to P of x divided by Q of x. Now, P of x and Q of x are two polynomials of any degree. For example, R of x equal to minus x plus 1 divided by x squared minus x plus 3 is a rational expression. And you see here, R of x is equal to minus x plus 1 divided by x squared minus x plus 3. Minus x plus 1 is P of x. X squared minus x plus 3 is Q of x. Now you can see this is a polynomial of degree 1. This is a polynomial of degree 2. You can write more examples just replacing another polynomial here and here, and you get another rational expression. For example, I could write that R of x is equal to minus x squared plus 3x to the power 3 divided by 5x plus 10. Now again here you can see that R of x is equal to minus x squared minus 3x to the power 3 is P of x. And here 5 of x plus 10 is Q of x. With a rational expression in a given number. Do you remember we studied how can we actually evaluate a given polynomial in a given number? Let's consider a polynomial P of t is equal to 1 minus t to the power 4. This was a question in midterm 2 as well. For example, if I want to see how much is the value of p when t is, for example, equal to 0, what I do, I simply substitute 0 instead of t in the polynomial. I write p of 0 is equal to 1 minus 0 to the power 4. Now this is 1, 0 to the power 4 is 0, therefore the value of p at 0 is equal to 1. The same procedure is applied when we want to evaluate the value of a rational expression in a given number. Let's see how it works. Suppose we are given a rational expression as R of x to be equal to minus x plus 1 divided by x plus 4, right? Now you can see that in this rational expression, P of x is minus x plus 1, which is a polynomial of degree 1. X plus 4 is another polynomial, which is Q of x. It's also a polynomial of degree 1. Now, if I want to evaluate this polynomial at a given number, what I do is only substitute x with that given number. Suppose I want to evaluate this number at x equal to 9. Okay? What I do, I just replace x with 9 here as well as there. There is minus x we have, therefore I write minus 9. Here we have plus x, therefore I write plus 9. So we got two numbers, one number here, one number here. Let's see how much are they. Minus 9 plus 1 is minus 8. And 9 plus 4 is plus 13. Therefore, it is minus 8 over 13. What you can say is that if x is 9, the value of this rational expression, is minus 8 over 13, which is a number. We could continue evaluating this expression in more numbers. Suppose we want to evaluate this polynomial at x is equal to minus 4. So what we do, we substitute basically, instead of x, what? Minus 4. Minus 4 instead of x, plus 1 we already have there, and minus 4 plus 4. Okay, let's calculate how much is the expression here, how much is the expression here. Minus 4 is plus 4 plus 1 divided by. Minus 4 and plus 4 is 0. We got 5 divided by 0, which is undefined. This means that we cannot evaluate a given rational expression in all numbers. There are certain numbers, or one number or more numbers, in which we cannot find the value of the rational expression. As we have seen, in some numbers we cannot evaluate a rational expression. And those are the numbers or the values of x which make the q of x where the denominator is 0. Expression or x is equal to x squared minus 1 divided by x plus 1. Now if I want to find in which value of x the value of this rational expression does not exist or undefined, what I do, I let this denominator to be 0. That means I let x plus 1 to be 0 and solve this equation. Well, this is a very easy linear equation. Let's solve it. From here, x is equal to minus 1. Minus 1 is the number or that value of x for which I cannot evaluate this rational expression. Why? Because this minus 1 makes the denominator 0 and the division by 0 is not defined. The outcome of this division is undefined. Therefore, I say that the value of this rational expression can be found in all numbers except minus 1. Except minus 1. Why? Because minus 1 makes the denominator 0 and that is undefined.